Welcome back. It's been a hot minute, but let's get into it. We have several more applications for linear programming to look at, a few more tips and tricks when it comes to working with our templates, when it comes to working with some of the cell commands that Excel loves to offer us. So I'm very excited to get into these. And also it gets to showcase just how everyone's got a little something to contribute, and everyone's got their strengths and everyone's got their weaknesses. So to start us off, we are going to start with an assignment problem, which usually is fairly straightforward. Your author usually likes to describe it as having one supply and one demand, but really that's not generally the case. And in fact, your author went as far as to show that themselves by making this one of the examples out of the homework section. I think this was number 35 or something like that. It actually had a typo to it, just to get started with this. It actually read originally that there were 2 games that each person could go to, but I'll get to that. There are 4 friends. They have 2 season tickets to the New York Giants. There's 8 home games, and so because of that and the 2 season tickets, that's 16 games. Split among 4 friends is 4 games apiece. So that's a typo that needs to be fixed. And what this is a table of preferences. Who wants to go to which game the most? The Cowboys is in high demand. Everyone except for Dave really wants to go to that. And the Cardinals is in fairly low demand. No one really wants to go to that. So the goal here is to figure out who gets to go to which games. Only 2 people can go to one game at a time. 2 people to each game, to make everybody the happiest. And since the preferences are from 1 being the highest to 8 being the lowest, we're going to want to basically assign these people to these games and minimize the scores, minimize their values. So if we were to do this by hand, we could. There's a finite number of possibilities. Could well be that Al and Carol go to the Cowboys. It could well be that Dave gets to go to the Redskins game and Barbara gets to go to the Jets game. But then after that, who really knows? So instead, let's look at using tools. So one thing you might jump into is pulling up our QM Friend software and pulling up an assignment problem. Well, I've got 8 assignments, I guess. So that's not quite right. I kind of need more functionality than this. And if I pull this up, I don't know what I'm going to get. Well, I mean, I do because I've done this before, but Excel QM, when it comes to their assignment templates, it's going to have the definition, 1 job, 1 thing. Can only assign 1 job per machine, can only have 1 machine per job. But that's not what we're actually looking at in this situation. I've got 2 actors, 2 people doing every game, and I want them to be assigned to 4 games. So 1-to-1 is not actually the case. So instead, for assignment problems, I really don't recommend that you use Excel QM. For assignment problems, I would recommend that you use, unsurprisingly, the template that I prepared. So let's get this stuff transcribed. Move this outside. Move it up. Okay. So I've got, let me do it this way. Al, Barbara, Carol, and Dave. I kind of like having actors being people and jobs being places. But that's me. And we'll get to deleting those other rows and columns here in a second. So Al has his preferences this way. Barbara has her preferences this way. Carol has these preferences. And Dave has these preferences. Now we'll delete these extra actors because we're only assigning 4 people. And we'll delete that both tables. And then we'll delete our extra jobs. Okay. And because the reality of it is you don't always assign one job to one person. You can assign more than one people or to more than one job. We have all this extra stuff to work with. So I want to send every person, right? Every person goes to 4 games. And every game has 2 people going. And just to prevent any weird stuff from happening, I'm going to want to send no more than one person to one game at a time. Al can't go to the same game twice. That's not really going to fly. So I'm going to have the max Sal value to 1 here, and I think that's going to be good. Once we have all that, it's really just a matter of pulling up Solver. I already have all the constraints baked in that you could possibly want. So we'll just click Solve, and we have a solution. I have several students who will not get a solution here, and that's not ideal. Because if you see an exclamation point here and it says Solver could not find a solution, the numbers that it moves around aren't ideal. But we did find a solution here. We do have something that works, and actually we have the best something that works. This is our optimal solution. And it works out that Al goes to these 4 games, Barbara to these 4, Carol to these 4, and Dave to these 4. Alright? And it works out also that every actor, every person goes to 4 games, which is great, and every game has 2 people at it. Perfect. And so that's our ideal solution. As far as happiness goes, Barbara and Carol are the happiest. Al and Dave a little less pleased with their choices, but they get to go to NFL games, so I guess they're okay with that. But anyway, one more thing, then we'll pause it here. If you had done this problem the way it was assigned, or the way it was spelled out in the problem statement, everyone only got to go to 2 games. So running Solver again, you see how it breaks. Because that's not actually physically possible. You cannot send 2 people to every game and also have at every game 2 people. It can't work out that way. So if you want that to work, you also need to set it so that you can only have 1 person at a game, essentially only allowing them to have 1 season ticket. And if you do this, you will get another solution, and it's now still favoring Carol, but everyone else is a little less happy. And also, they only get to go to 2 games instead of 4, so it's really not ideal. But hey, there we go. That is what I recommend for assignment problems. We can go into the linear programming constraint aspects of it, but you should understand the gist of it. And in the next video, for the other examples, we will pull out some more linear programming. So I'll see you then.